As a young citizen of India, armed with technology, knowledge, and love for my nation, with a vision of transforming India into a developed nation, I am joining Shobhit University. What about you?
I need to open it and it need to download.
Dr. Patil, you can look at me. Very good morning to all the participants from India and abroad. Shobhit Institute of Engineering and Technology, Meerut, deemed to be university, and its centers of excellence, Center for Informatics Development Solutions and Application, and Center for Industry 4.0 Technology Studies and Application, in association with African Asian Rural Development Organization, ARDO, New Delhi, organized this weekly international webinar series on open source digital technologies towards self-reliant India, Atmanirbhar Bharat. Today is 83rd edition of the webinar series, 16th July 2022. This webinar is being held on every Saturday at 11:30 a.m. to 1 p.m. Indian Standard Time. On behalf of the Honorable Chancellor, His Excellency, the Secretary General ARDO, Honorable Vice Chancellor, the faculty members of the university, and on my behalf and as a Professor Emeritus and Chairman of Centers of Excellence, Center for Agricultural Informatics and E-Governance Research Studies, Center for Agribusiness and Disaster Management Studies, Center for Informatics Development Solutions and Applications, and Center for Industry 4.0 Technology Studies and Applications, and Center for Health Informatics and Computing. Let me welcome our guest speaker of today's webinar on the topic Data Mining on Digital Agriculture, Dr. S.S. Patil, Professor of Computer Science, University of Agricultural Science, Bangalore. I wish to inform the participants and the guest speaker that under this international webinar series, these two centers of excellence, Center for Informatics Development Solutions and Application and Center for Industry 4.0 Technology Studies and Applications, have organized so far 82 lectures on very important topic, namely open technologies to provision simple and economical IT infrastructure, a roadmap for students using free and open source software and reaching goals of Atmanirbhar Bharat, free and open source software adoption and business models, open data platform for smart digital government, technology imperatives, make in India for self-reliance, edge artificial intelligence, data governance for self-reliant India, digital India, transforming governance and society, by Dr. Y.K. Sharma, former Director General, National Informatics Center, India's email service, citizen@indiamail.com, in 22 constitutionally recognized languages, by Dr. Seema Khanna, Deputy Director General, NIC. Ecosystem architecture for digital transformation, by Shri J. Satyanarayana, former Secretary to Government of India. Education system cyber critical infrastructure, seizing opportunities in open innovation and value creation network in the digital world for self-reliant economy, by Dr. Jababale Vinanchi Ararchi, former Principal Advisor to the Director General, UNIDO, Vienna. Ensuring food safety and compliance through technology, Digital India, urgent need for semiconductor manufacturing in India, technology investment in agriculture value chain, role of foreign direct investment, by Dr. Dhanendra Kumar, former Executive Director, the World Bank, and former Chairman, Competition Commission of India, Government of India. Entrepreneurship and skill development, AI design pathways, rise of platform economy, revisiting value chain governance, era of automation, industrial robotics, and Industry 4.0, India-German perspective of technology transfer, skill gap analysis and opportunities, role of artificial intelligence in healthcare, current developments in diagnosis and vaccine research, digital agri-tech and agri-startup perspective, health informatics network value chain, e-health systems and beyond, leveraging emerging technologies for ensuring transparent and traceable agri and food supply chain, E-governance models towards sustained quality services to citizen factor by technology, Dr. V.S. Raghunathan, Deputy Director General from National Informatics Center. Indian MSME to adopt Industry 4.0 technology capabilities, urgent need for mentorship and accelerator program. Building public digital platform using microservices and APIs by Mr. Pawan Kumar Joshi, Deputy Director General, NIC. Health Informatics Network Value Chain, Early Childhood Development and Learning. Health Informatics Network Value Chain, Clinical Artificial Intelligence. Interface between machine learning and health informatics. Health Informatics Network Value Chain, Importance of health, social medicine, and community health in the times of health emergency. Gravity filter, simple low-cost solution to the drinking water treatment in rural India. Open source GovTech startups empowering growth with automation. Digital transformation in small enterprises and small businesses of India, challenges and opportunities. National Digital Twine Program, need for a robust geospatial infrastructure. Industry 4.0 in MSMEs, benefits of indigenously developed collab CAD from National Informatics Center. Mass serialization and anti-counterfeiting solutions to fight illicit trade. And young entrepreneur, Mr. Johnny Somerville. Cybersecurity risk challenges and solutions, intelligence approach to reduce cyber risk. New Internet IPv6 root server toward Atmanirbhar Connected Bharat. Indian startups, reflections and possible policy intervention needed for scaling up to Gram Panchayat. Blockchain and crypto for digital assets platform, pathways for global trade. Robot as a service, leverage technology to solve enterprise challenges. Space startups, connecting to international markets with the emerging business model. Enabling technologies for future vision. Vivekananda Secondary Education and Skills Development Mega Project, its potential impact on rural entrepreneurship and the rural economy in India. Sports Grail, a digital sports media platform, prospects of Indian sports industry, sustainability model at global level. Pharma 4.0, Industry 4.0 applications to pharmaceutical manufacturing, path to a digital transformation. Accelerate and scale non-linear growth through partner ecosystems. Technological renaissance and the human capital, a perspective. Health Informatics Network Value Chain, a medical outreach, challenges and potential, and NGO working in Nilagiri Forest. Beyond COVID-19, revitalizing micro and small enterprises. Project management essentials, launchpad for future CEOs and startup founders beyond. Society 5.0, a new society beyond Industry 4.0 and post-COVID-19. Smart village, a new and community, the African ICT / IoT lessons. Digital economy, ways it builds to protect and empower for self-reliance. Pragmatic base for Atmanirbhar Bharat. Democratization of essential services by using sustainable energy as a catalyst by Dr. Harish Handle, Raman Magsaysay awardee in 2011. Transforming India through relevant education and vocational training. Digital technology in simplifying citizen life. Unlearned learning during the pandemic and its future by Professor Saeed Khan, former professor, Jamia Millia Islamia. Smart microeconomic zone, pathway for self-reliance at village. Crime prediction support system by Dr. E.G. Rajan, Chairman, Pentagon Group of Companies, Hyderabad. Knowledge management for development partnership to achieve the sustainable development goals of the United Nations and implementing the Agenda 2030. Millet value chain from IoT to blockchain, a traceability roadmap. Aspirational district program in left wing extremism affected district, a successful model of data-driven governance. Digital agriculture supply chain and trading hub, a geo-economic perspective by an NRI, Mr. Maya Suresh Kannan, based at Canada. Market-driven agriculture, need for development of crop-specific strategic at block level. An open agri network to unlock the $1 trillion plus potential of Indian agriculture with smallholder farmers, by the founder and group CEO Samunnati, India's largest agri-tech enterprises, Chennai, developing rural entrepreneurship to ensure doubling of farmers' income. Resident representative of the World Bank Group, Mr. Devashish Mahapatra, Lucknow, leveraging the power of convergence through connecting the dots, agri-startup, agripreneurs, and rural innovators, by the CEO NABARD Foundation, Mr. Sanjeev Rohilla. Agronomy plus artificial intelligence is equal to precision farming. Doubling farmers' income, imperatives of plant health informatics network. Developing commercial breadfruit value chain to help farmers reach high value markets. Commodity value chain creation through AgriNet and Agri-AI by Andrew Gavagan from Melbourne, Australia. Farm to Plate, a one-stop agri-tech platform to simplify supply chain e-commerce needs of food and perishable commodities. In this case is fish. It is operationalized in the state of Andhra Pradesh. Health Informatics Network Value Chain, National Animal Disease Reporting System, NADRS 2012 and beyond, by Dr. Praveen Malik, Animal Husbandry Commissioner, Government of India. Artificial Intelligence, Metaverse, Frontiers in Workspace. Coconut Value Chain Challenges, Transforming into Opportunities, by Dr. P. Ratnam, former Executive Director, Asia Pacific Coconut Community and former Chairman, Coconut Development Board. And Coffee Informatics Value Chain, facilitating smallholder coffee farmers into business, and young startup Dhanalakshmi Arun of Tokeni Group, Tokeni Coffee. And Health Informatics Network Value Chain, building of one health ecosystem. Role of digital architecture, by Dr. Sindhura Kanapati, visiting PSA Fellow, Office of the Principal Scientific Advisor to the Government of India. And Senior Visiting Scholar, Huck Institutes of the Life Sciences, Penn State University, USA. Diversification of fish and fisheries resources management and its challenge in Bangladesh, by Dr. Binay Kumar Chakravarti, fisheries scientist of the Department of Fisheries, Government of Bangladesh. Today is the 83rd edition of this very important webinar series. We'll have the talk by our guest speaker, Dr. S.S. Patil, Professor of Computer Science, former University Head, Department of Agriculture Statistics, Applied Mathematics and Computer Science. Very good combination. University of Agriculture Science, Bangalore. And he will talk on a very important topic, data mining on digital agriculture. Data mining on digital agriculture. Many times we will see the topics, data mining in agriculture, data mining on agriculture. But today the title is data mining on digital agriculture, because a lot of data comes out by digitalizing agriculture. What will you do with that? The keywords are data mining and digital agriculture. Atmanirbhar Bharat is the mission of our Honorable Prime Minister, Shri Narendra Modi, of making India a self-reliant nation, rested on 5 I's: intent, investment, inclusion, infrastructure, and innovation. In intent, infrastructure, investment, inclusion, and innovation, based on 5 pillars. Quantum jump in economy, not incremental, quantum jump. Infrastructure, one that represents modern India. System, 21st century technology driven. Vibrant demography. Demand, whereby the strength of our demand and supply chain should be utilized to full capacity. This was rolled on 15th May 2020. And during the third tranche of Atmanirbhar Abhiyan, To boost Atmanirbhar Bharat in agriculture, the government of India has given 1.5 lakh crore as the booster to facilitate farm gate infrastructure, rupees 1 lakh crore to agriculture cooperative societies, farmer produce organization and startups. 10,000 crores for formalization of micro food enterprises and for following cluster-based farming approach. 20,000 crores for Prime Minister Matsya Sambada Yojana to pay for additional fish production of 70 lakhs ton over next 5 years. 13,000 crores to achieve 100% vaccination of cattle, buffaloes, sheep, goats, and pigs. 15,000 crores for animal husbandry infrastructure. 4,000 crores for promotion of herbal cultivation to cover 10 lakh hectares under herbal cultivation in 2 years, and 500 crores for beekeeping initiative. These are all to strengthen vocal for local to make it global. And these reforms announced have been systematic, planned, integrated, interconnected, and futuristic for creating strong enterprises, generating employment, and robust supply chain. Agriculture sector is the foundation of Indian economy. India lives in village. Acharya Vinoba Bhai said India is largely an agrarian agricultural country, Krishi Pradhan Desh, and a country of villages, having more than 6.25 lakhs villages. And at present, agricultural livelihoods are being severely impacted worldwide as a result of anthropogenic global warming and climate change. It has got both the direct and indirect effects on agricultural productivity, including changing rainfall patterns, severe drought, flooding, and changes in the geographical redistribution of pests and diseases. And India's labor-intensive and subsistence-based agriculture sector is particularly vulnerable to this development. Farmers of India are facing multidimensional problems: price fluctuation, debt and infrastructure, lack of infrastructure, and weather. It consists of about 14.5 crore operational holdings, and after which 85% of the farmers are having small and marginal operational holdings, having less than 2 hectares of land holding. They need timely, location-specific, and personalized information for effective control on their production, risk, and then market their produce to identify market opportunities. Many national level programs such as Digital India, Make in India, Skill India, and Startup India, Stand Up India, and Grown Up India startups have faced operational difficulties for its impact at farm level and farmer level, that too at small and marginal farmers. Our Honorable Prime Minister said in his Independence Day address on 15th August 2021, I quote, "In the coming years, we will have to increase the collective power of the small farmers of the country. We have to give them new facilities. They must become country's pride. Chota Kisan, Bane Desh ki Shan. Small farmers become the pride of the nation." On 16th April 2022, he said once again, I quote, "India cannot afford to remain stagnant at this juncture, and it has to be self-reliant. And if people use local goods for the next 25 years, the country will not have to face the issue of unemployment, while urging the people to buy only locally made products." On 20th February 2016, he said, while addressing the farmers' rally in Bareilly, Uttar Pradesh, I quote, "My dream is to see farmers double their income by 2022 when the country completes 75 years of independence." And feature smart farmers. Urgency of democratizing foresight. I would like to quote from the report of GFAR Secretariat. The future is an area of increasing uncertainty. Though the future cannot be predicted, it can be explored. Exploring the future helps making better decisions in the present time. It opens new paths unveils new options, and enlarges our understanding of potential unexpected effects of our decision. At a time when climate smart agriculture is taking momentum in the international community, the urgency of more future smart farmer organization equipped with the decision making capability with analytics and data mining, and local communities become imperious. The voice and views of the future smart farmer organization and local communities are needed to influence the national and international agenda. And I would like to quote the Doubling Farmers' Income by 2022 report, 2018, with which I have been closely associated as a group leader for 2 volumes. Volume 11, Empowering the Farmers Through Extension and Knowledge Dissemination, and Volume 12B, Digital Technology in Agriculture. And this report suggested 7 mission mode programs. As I was involved from 1985 onwards and as the project director of District Information System Program, which suggested 28 sectoral database development program, data development, and comprehensive village level information system. If these 29 programs would have been operationalized with Sprit, today we would have got a lot of data at the grassroots level with artificial intelligence and big data analytics, and with the data mining capabilities. We would have brought in what the small farmers wanted. It would have been informatics-led agriculture. And these 7 mission mode programs, and 1995, I was instrumental in bringing out 15 blueprint, having 15 informatics network, AgriSnet, AgMart, and so on and so forth. We asked for 3 to 6% of the agriculture budget as an IT budget for agriculture, even before internet came to India, and also that national e-governance program was announced, that is 2005. This blueprint was evolved for agriculture in 1995 by National Informatics Center and Ministry of Agriculture. The 7 mission mode programs are, if it is operationalized, it is waiting for its operationalization since September 2018. They are digitalized agriculture, digital technology and innovation in agriculture, synergization of Digital India, Make in India, Skill India, and Startup India for transformational reforms in agriculture sector through smart rainfed farming, smart irrigated farming, and smart tribal farming. Digitalized agromet advisories and agricultural risk management solutions. We have to adopt open insurance ecosystem. Digitalized agricultural resources information system and micro level planning for achieving smart village and smart farming. Smart village as a scheme, I was instrumental in getting approved by the then Planning Commission in 2002. Digitalized value chain for about 400 agriculture commodities. Digitalized access to inputs, technology, knowledge, agricultural finance, credit and marketing and agribusiness management to the farmers. Digitalized integrated land and water management system. And the last one is very important, digitalized farm health management for reduction of farmers' loss. This is itself is $1 trillion data economy. That is population, human health, plant health, animal health, soil health, water health, fish health, and environmental health. 85% of the disease which the common public gets are from animal. COVID-19 pandemic situation is one such, COVID-19. And this is a very important, using GIS technology and over village, if this 7 vertical silo of health related parameters are laid and analyzed, and any country need not go for national lockdown for any account of future pandemic situation. Digital India program aims to transform India into a knowledge-based economy and a digitalized, empowered society. And on 20th February 2019, Ministry of Electronics and Information Technology published a report titled India's $1 trillion Digital Opportunity. And this report identified 30 digital themes. If scaled up nationally, can accelerate India's progress in 9 key areas. And 10 emerging technologies are making impact. They are artificial intelligence, 5G, 6G, IoT, serverless computing, biometrics, augmented reality, virtual reality, blockchain, robotics, natural language processing, and quantum computing. We have 3 frameworks. Agriculture 4.0, India has to achieve. Industry 4.0, it was announced in 2014. We got about 63 million SMEs. The technology 4.0 is yet to tap the door of all MSMEs in this country. And then society 5.0, industry 4.0 has come from Germany, and society 5.0 has come from Japan, and India has to give to the whole world agriculture 4.0. And India has a strategic plan for achieving new India. That strategic plan is titled Amrit Kaal led up to 100. That is for the next 25 years, from India at 75 to India at 100, 2047. And we also have 17 sustainable development goals and 169 targets to be achieved. This is a future which we want. And leveraging the power of convergence through connecting the dots, agri-startup, agripreneurs, and rural innovators at the grassroots level is very important. And with the 7 mission mode programs of the digitalization of Indian agriculture given by the Doubling Farmers' Income by 2022 report submitted to Government of India in September 2018, can facilitate 2.25 lakh agri-tech startup, 1 per each Gram Panchayat. This sector alone can bring out highest number of agri-tech startups in the country. And value chain development is more important. All 400 agriculture commodities, because India grow agriculture through 127 agroclimatic zone in 365 days. We get sunshine in all 365 days. We get more rainfall than Israel. But Israel agriculture productivity is enormous and super. We have to achieve that level. And value chain development brings all the stakeholders engaged in the production system and on a common platform to contribute their best while ensuring fair deal and transparency. We have to have a block level value chain, district level value chain, regional state level value chain, national level value chain, and global level value chain. It has to be integrated. And this is very important, and it will be a market driven value chain from consumer to supplier that will be blockchain enabled. And health informatics network value chain, I said it is a $1 trillion data economy. I visualize that maybe 10 years from now, India will have a data center with 10,000 data scientists and doing data mining, data analysis on health informatics alone. All biology students with AI and data analytics and blockchain technology can be converted this area into a $1 trillion data economy. Are we ready? This is the first university, private university, to have a center for health informatics and computing to train BSc biology, biotechnology students and +2 biology and other technology components, students to get into, health informatics program. And data mining on digital agriculture is today's topic. In the Doubling Farmers' Income Committee report, we suggested Farm Extension 4.0. Today, you have only Krishi, Vigyan, Kendras, about 625 for the number of districts is 753. China has got more than 6 lakhs agricultural skill centers. And we need to have at least minimum 2.25 lakh agri-skill center, skill development centers through agri-tech startups at the Gram Panchayat level. This 12 area which we have suggested can generate agriculture extension as a digitally enabled extension and to help 14.5 crore operational holders. It's very important. And agriculture extension ICT has to be, integrated. The drivers for future agriculture are internet of things, artificial intelligence, spatial technology, geometrics technology, blockchain technology, and cloud computing, fog computing, edge computing, mobile computing, social media, big data analytics, and smart farming. And as we know that farmer and farm generate a lot of data from their farm management practices, but these data are not systematically captured for subsequent analysis and interpretation through information technology for strengthening agriculture value chain. However, the farmer who generated data needed to agree upon data use and sharing with other shareholders. He doesn't own the data. And as we know, data mining is a process of sorting through large data sets to identify pattern and relationship that can help solve business problems through data analysis. Data mining techniques and tools enable enterprises to predict future trends and make more informed business decisions. Data warehousing is a method of organizing and compiling data into one database, whereas data mining deals with fetching important data from databases. Data science versus data analytics, it's two sides of the same coin. And data science and data analytics deal with big data, each taking a unique approach. Data science is an umbrella that encompasses data analytics, data science that encompasses data analytics. Data science is a combination of multiple disciplines, mathematics, statistics, computer science, information science, machine learning, and artificial intelligence. And data is growing at a fast pace, faster than ever before because of IoT, which generates a lot of data. And in daily operation, I would like to quote a very important article which was published on 9th July 2021. And the title is, What is Data Mining? How it works, techniques, and example. To brief the audience. In a daily operations, a business collects data about sales, customers, production, employees, marketing activities, and more. Data mining can help businesses extract more value from that critical company asset. That is, data mining can help extract more value from that critical company asset. That is a data set. The knowledge gained through data mining can become actionable information a business can use to improve marketing, predict buying trends, detect fraud, filter emails, manage risk, increase sales, and improve customer relationship. Data mining is a collection of technologies, process, analytical approaches brought together to discover insights in business data that can be used to make decisions. It combines statistics, artificial intelligence, and machine learning to find patterns, relationships, and anomalies in large data sets. Top 10 data mining techniques for business successes. They quote it. It is from the published documents. Anomaly or outlier detection, association rule learning, clustering analysis, classification analysis, regression analysis, data warehousing, visualization, statistical techniques, tracking pattern, and sequential patterns. And this is almost 10 important data mining technique which we have to equip with the agriculture science graduate, with the students and the engineering students and the students from non-engineering colleges who learn computer science and applications. And well, I was addressing on 11th October 2018 in Vibrant Gujarat Startup and Technology Summit. I was given the topic analytics, data, image, audio, text, a game changer for rising farmers' income. Agriculture, the 14.5 crores operational holders generate data. They can generate images now today with a smartphone, and they can also get audio clippings and lot of published textual knowledges. And farmers also can generate textual knowledges, textual things through in local languages, 22 constitutionally recognized knowledges. But if this data gets generated in the form of audio, voice, audio, image, textual data, numerical data, and local language data, and these data have to be analyzed to rise farmers' income. Are we ready? And then there are a lot of data analytics software systems available. It is being taught in the statistical discipline, but I do not know whether the people who deal with information technology are being talked about it. There are towards $1 trillion digital economy through Digital India programs. 9 pillars Digital India has announced. Smart Village 2002, I was instrumental. Smart City 2015, our Honorable Prime Minister has announced, and the country needs geospatial enabled digital twine program. Day by day, data increases takes place, but the data mining, data analysis doesn't take place that. And we have a National Digital Communication Policy 2018, which would like to bring in higher bandwidth data connectivity to every house. They will generate data. So data mining is often referred to as a knowledge discovery in databases. In computer science, data mining also known as information discovery from databases. Today's topic is data mining on digital agriculture. Data mining in agriculture is a very recent research topic. It consists of application of data mining techniques to agriculture. Recent technologies are nowadays able to provide a lot of information on agriculture-related activities, which then can be analyzed in order to find important information according to definition available in Wikipedia. But I would like to quote from an article which is titled The Impact of Data Analytics in Digital Agriculture, a Review 2020, which is presented in an international multi-conference on organization of knowledge and advanced technologies. It says, advanced development of information and communication technologies and its adoption in agriculture area are open up the field to the appearance of digital agriculture, which created new processes for making farming more productive, efficient, and controllable while respecting the environment. Data science and machine learning is among the key of information technology used in digital agriculture for their ability to analyze a vast amount of data, to extract new knowledge, and to help agriculture understand better the farming task and make better decisions. Big data, in its turn, offer a support to farmers to extract new insights from the data to make more accurate decisions. Data analysis and mining process become routines in all the sectors of economy where the data sets are available. Now, this is more important. The challenge now is to how to exploit all this large amount of knowledge that is previously known for efficient decision-making process. Until recently, much of the knowledge gained through a number of years of research is stored in static knowledge bases or ontologies, while more diverse and dynamic knowledge acquired from data mining studies is not centrally and consistently managed. In this research, we propose a novel model called ontology-based knowledge mapped to represent and store the results of data mining in crop farming to build, maintain, and enrich the process of knowledge discovery. And there are a lot of data mining techniques applied on agricultural data. We have big data sources as a media, cloud, web, IoT, and databases. And I also would like to quote, recently in 2021, the Niti Aayog, National Institution for Transforming India, has launched a national data and analytics platform, NDAP, to see the data in an analyzed form of Government of India, which collects. The Ministry of Statistics collects. Indian Statistical Commission has it. This NDAP seeks to democratize data delivery by making government data sets readily accessible, implementing rigorous data sharing standards, enabling interoperability across the Indian landscape, data landscape, and providing a seamless user interface and user-friendly tools. As per the synopsis of the guest speaker he shared with us, I would like, for the benefit of the participants, to warm up. Digital data acquisition is a challenge in agriculture and an allied sector, as data are in diverse forms, as fragmented, replicated, unorganized, unstructured, semi-structured, and structured. Hence, we need to have normalized data, despite big data approach being only a solution. Agriculture science and allied sciences such as horticulture, sericulture, apiculture, forestry, have cultivation system as more or less common in nature. The cultivation subdomains are agronomy, soil science, breeding, physiology, microbiology, pathology, entomology, biotechnology, engineering, economics, marketing, and agribusiness, wherein data are interrelated to each other. And this has to be studied. In such a scenario, comprehensive solution is required to the farming community to overcome the indecisive decision approaches of uncertain agroclimatic conditions and market fluctuation behavior. And we have to give a comprehensive solution to the farming community. And data mining provides knowledge and information to the farming community, like the prediction from meteorologists and demand-driven cropping patterns, yield of crop, livestock, fisheries, market arrivals, buyers' behavior, and consumers' loyalty, and crop risk of various diseases and mitigation. Cooperative societies can take decision. He's advising. They can take to global market-driven uniform crop, whatever the crop which are being produced by the members of the cooperative society. They can adopting a good decision-making process of the local environment. They can early adopt of new practices and the distribution of skill orientation and cluster-based control of various disease mitigation as well as insect attacks. He is proposing a complete agricultural value chain, which no primary agriculture cooperative societies are having it. And he also says that what researchers should do, they can view the agriculture and allied sciences as an industry, another industry, with the integral form of raw material supply chain, an industry 4.0 supply chain, and startups shall design supply chain as a booster to farmers' income, scientific pricing system, and linkages between consumer and their satisfaction. So, data mining provides prediction to infer sufficient knowledge through regression-based farmers' income and cost of cultivation of crops, and facilitates to determine production and prices. This webinar will address holistic approach through data mining on digital agriculture to increase farmers' income and usher in smile on their face. With this background, let us turn to the address by our guest speaker, Dr. S.S. Patil, Professor of Computer Science, former University Head, Department of Agriculture Statistics, Applied Mathematics, Computer Science, University of Agriculture Science, Gandhi, Krishi, Vigyan, Kendra campus, Bangalore, on a very important topic, data mining and digital agriculture. This topic will motivate and galvanize the participants watching over telecast through facebook.com/Shobhit University India or youtube.com/Shobhit University in or linkedin.com/company/Shobhit University for motivating them to get inspired to work in the area of data mining in digital agriculture as part of farming as a service by establishing agri-tech startups at Gram Panchayat levels. I invite our guest speaker to address the webinar. Before that, I introduce the speaker to the audience, Mr. Manish. Dr. S.S. Patil is a professor of computer science, former university head of the Agriculture Statistics, Applied Mathematics and Computer Science, University of Agriculture Science in Bangalore. A doctorate with quality publications in reputed international journal and conference proceedings. A track record of first-class results in the entire career. More than 25 years of research experience and 35 years of teaching experience at postgraduate and graduate level and 2 years of industry experience. Guided over 15 MSc as chairman and 90 as advisory member, and seven PhDs as a chairman and 60 as advisory member to the student in his 25 years of academic research and 35 years of teaching. Author of books titled Pattern Classification of Grass Genome Sequences, published by Lampard Academic Publishing, 2012. Data Mining and Computational Biology and Bioinformatics, published by University of Agriculture Science, Bangalore. Reviewed several PhD and MSc theses, international and national journal articles and conference papers. Headed the session chair of many conferences, member of selection committees of professors, assistant professors of computer science and bioinformatics of universities and institutes, and also member of several scientific bodies. Delivered more than 50 invited special lectures to many universities and institutes. His research interests are data mining, soft computing, computational biology, bioinformatics, pattern recognition, and geoinformatics. With this, I invite Dr. S.S. Patil to address the international webinar series on open source digital technology towards self-reliant India, Atmanirbhar Bharat, on very important topic, data mining and digital agriculture. Over to you, sir.
Thank you, Professor. Gurubhyo Namaha. Actually, I need to pray the God as a teacher who is inspired me to be a data mining, igniting me the knowledge of this data mining as a professor, M.N. Murthy, Indian Institute of Science, Bangalore. He was a professor and head and even in the dean of the engineering faculty. He guided me the good way to move into this data mining approach. So with this, Professor Moni has already covered all my topics, which I have been necessary to address here. So he has a good statistics and he has a good narration about what are running so far. So my objective is actually the two giants. One is the digital world giants are there in the computational science. Other side, agriculture giants are in the production sides. They have been proved. Agriculture people have proved that green revolutions and it feed the whole world without interruption. So that is a major contribution to this world. As well as the digital peoples also in the 1998, the data is now they are using, everybody having the mobile. Nearly more than 40% of the people of the world is using the mobiles. But without that ISDN technology, 1998 ISDN technology, we couldn't able to reach this all the facilitation. So these two data are other side. Data are generating like a exponential rate, but various sectors like business, communication, service sectors, health sectors are already covered, but agriculture sectors are still is unorganized. So that data should be organized and bring into the industry fashion. Then it should be get more returns. People will be more attractive to be invest in this area, and it will be make a meaningful for the farmers face smile. But ultimately, that is only the solution what I felt it. So God is given the lot of facility, like is given the five elements like Bhumi, Agni, Jala, Vayu, Akasha, means sky, air, water, and soil, earth. These are the five elements, and sun and moon are used to rotate the soil that earth is rotating. So they're creating the so many data aspects of the geo and environmental nature data concepts, whereas is generated the another area like a shall I make this widen? So okay, fine. So this would be the okay. So they have been given the opportunity to live in this world as a human being as well as a animal living organisms like 84 lakhs, that is the objects there. Well, fine. So these data one side, the people are necessary to understand how to utilize this as a geo data, digital data as well as the bio data to be integrated and derive the good knowledge from this. This is the major challenging task. Like data are already explained by Moni, Professor Moni ji. Data sets, then data marts as a smaller units, then it should be developed by the database, then big data and data warehousing and cloud era. So many now people are still under research. Every day it will be go on changing. You can't able to, you can make the list of the statistics one side, but alternative day you are obtaining the new evolution of the evolutionary in this data sciences. But other side, that agriculture is also very important task. That agriculture people are speaking only agriculture, veterinary separate, horticulture separate. They have their own approaches of the object, but aims. But ultimately, whole umbrella of agriculture is the one task. So, which task will be providing the integrated society in the various level of the populations can play the role with respect to the social fabrication of the living beings of their livelihood. So for that culture, so some of the area already explained that in the part of this agriculture cultivations can make the agronomy, soil science, and even in the breeding, pathology, entomology, and even in the agriculture engineering, marketing, economics, and so forth. These are all contributing a lot of their respective subject as a research. Then everyone have their giants in this research part. They are contributing a lot of things, but they have their individual own pockets. They have the data, but is not integrated data as a holistic way to not able to view it. If you go little away from the word, then you have to view the your word. It looks nice. If you come to the very short area or some clumsy or dirty area, you feel it, oh, whole world is looks like a dirty. So if you look into the holistic way, the data would be much better to look nice. So for that we require the ultimately marketing and as well as the other parts here. So that is a challenging task to be reaching the farmers can able to obtain their income in the better fashion. So in this approach, big data is big data approach has come up into the system. Earlier it was started with the V10 actually. Sorry, it is a V10. Earlier it was only V3. Later on it grows up to V5, then V10. V10 is data is the valueness, and second is velocity, the speed of change, and different form of the sources of the data that can variety, and variability of inconsistency in the data, as well as the uncertainty of the data. So that also veracity and even validity, that accuracy of that correct the data, and reliability of the security concerns. We can't meddle the data, and validity of irrelevant historic data also we can necessary to take out from that, and visualization of meaningful visualization data, visualization, and last, ultimately not least, that is the value. The data have the value which only mean as a knowledge. So these are the V10s are playing the vital role in the big data. The big data, I hope you are visualizing this, where it starts with us as a data facts, then we have been arrived to the knowledge. This is the approach by the big data. So this is architecture that is only related to the technology. You don't bother about that, the agriculture peoples, but ultimately you can support to keep the data into the particular architecture fashion. And data integration is necessary to the current architecture. Then various kind of data sources are there, and you have to be operate with the EW and CDS. Then ultimately you have to visualize in the reporting fashion what could be the knowledge given driven over there. Then similarly, this is the source ETL, and as well as the, so that ETL is also playing the vital role in the respect to the reporting the data operationals. And big data technology is the data ignitions, and Hadoop is the major source, is the way to be bring into that picture as a UG, PG, and EV, Hive, and even in the mouth and scoop. So these are the area we can address for the ad hoc query levels into the emphasis and prevents, no SQLs, and even in the no memory processing. So that such operations can ultimately reduce the map reducing and non-map reducing and distribution file systems, as well as the core component to be bring into the big data approach. The ecosystem is, Hadoop is a major source of ecosystems, can provide facilitate to the distributed file systems. And this is architecture of the Hadoops. You can keep the data in such a fashion that you have to block, you have to bring the block data, and you have to put the yarn over there, and you plug and play the any kind of computational aspects with any kind of analytics can happen to be performed there. So this approach will be providing better way to be the client as a metadata operation to be the block data operations, and that replication also be stored in the data nodes, and it can be read out and write into the other rack, and it can be provided the facilitate to the approach. So that big data Hadoop is not necessarily big data, you cannot keep it into the server, but it can be put into the cloud era, and so many works, Mapits, and AWS. So Apache Foundation techniques then provide the facilitate to this aspect. So with all this data, we have the kind of data with us. So what do we do does with this? So that is a big challenge over to this. That in interdisciplinary aspects, the data need to be input. Earlier it was only IPO, input, process, and output. What process does within that, that will be the million dollar question. Whereas in the data processing, we can make the feature selections, density reductions, normalizations, data substituting. So after that, you have to make to the data mining. The data mining, after that post processing, you are obtaining the filters of the patterns, visualizations, pattern interpretations. Then you have provided the informations. So ultimately, people need the relevant informations based on the data. The data is a one angle which cannot be understood only if you look at the data. But if you provide the information, people can understand the information aspects. The data mining core discovery knowledge can be provided the database and big data and data warehouse and relevant data and data mine it and pattern evaluations. So, and business approach also, it will be given the approaches of the data preparations, data exploration, data mining, and data presentations and decision making. The policy making also does it in the decision making levels. So that is also very important place in the part of it. Ultimately, the data mining is the architecture which use the data reductions, data comparisons, pattern discovery, probability theory, macroeconomic views, and inductive database. These are the area how to be addressed for the data architectures of the data mining. And ultimately, you need to provide the data query of return the exactly analyzing the intent of this query concepts. So for that, you require the graphical user interface, pattern evaluations, data mining engines, and which are the cloud era and data concept. With respect to the knowledge base, we have to be infer the knowledge from that knowledge base. The knowledge engineer infer and provide the facilitate to the every end users. So that are the confluence of this data mining. They are the statistics is already Professor Moni has given a lot of statistics about the agriculture and communication, digital systems, and all the projects and over the chronological order. But the statistics is a one side how to be design and analyze and interpret. The data mining have to be playing the vital role between the statistics as well as the algorithms like artificial intelligence, machine learning, and pattern recognitions. So, how to select the features? The feature selection is the major challenge. So, we have a lot of columns like attributes. That out of attributes, you have to search the strategy which attribute is the dominant over to the particular attribute can able to derive the knowledge for this. Then you have to make the subset of those attributes. Then you have to evaluate those attributes. Then it will be fall into the criteria. Then you can go to the select the attribute and validate the process. If not, then again you have to put into go back to the search strategy, then subset, then evaluation, then you have to do this aspect. For this data mining, once you start planning to data mining, here the main four cores of the data mining task are there, like classification, clustering analysis, association analysis, and predictive analytics. So classification, I would need to explain that. Why do you need to classify them? And what are the classifiers? How to be performed? What to be the cluster? And which cluster will be inter-cluster, intra-cluster aspects are there? Association of this any consumer goods and other parts, and predictive analytics of the many decision aspects. So for this, we have the life cycle of the data mining is necessary to be addressed there in that. What kind of data mines to be mining? It could be a matrix fashion format, it could be the set format, it could be the text format, it could be the sequence format, or it could be the time series format, it could be the image data, it could be the graph network. These are the various aspects. The even professor is told that even natural language processing also have the data kinds. That audio data and video data also necessary to be mine it. But whereas that should be converted into the different version of the binary number system, then it will be analyzed. So I come to my area right now, the data mining. We have the left side, I have the digital words, data science. Right side, I have the agriculture science. I have to be balancing and interacting between each other and obtain the knowledge from that agriculture science data through the data science. Then we can give the proper solution to this farming community. Otherwise, it is only haphazard and individual have to perform their respective task, but it's only focused on particular part, but it will be losing the holistic way. So whereas it starts with the soil and cultivation, cleaning I give the agriculture, but it's not expertise necessary. But here I'd like to say this cleaning the land preparations used to say, then we have to go for the sowing, then after sowing, then we can go for the fertilizers, irrigations, and weeding. Then I have to go for the pathology, means we need to controlling the disease as well as the insect management. Then harvesting, then marketing, post harvesting, harvesting and post harvesting, and marketing, economic involved in that. And food and nutrition. So everybody bother about that food, how it comes. Food means nowadays people are speaking about the Zomato or Swiggy or some or so on and so forth. But what behind in that agriculture science can be contributing a lot of tasks to feed the whole world as a food. Food is the god. Otherwise, you are not in the part of passion. So ultimately, the whole domain of this agriculture need to be a smart farming and controlling, and it will be managing and leading. All things can be happen to be addressed this. For that, timely you have to give the solution. Then only the solution have the value. For that, we have the some set of solutions here by the data mining through the data science. One is that you have to collect the data through the data warehouse, cloud, and big data, and many approaches. And then you start with the classification. You have to classify the various kinds. Whether you go for the classification of the land, classification of the macronutrients in the soil, or else classification of the seeds, and classification of this. What are the operations you can necessary to classify with respect to the what the farmers or researchers are interested over to that. Ultimately, the object-oriented concept to be necessary for the classifications. Then clustering, you have to cluster the groups, the homogeneous, either it is interclass or intra-class clusters with the different distance measures. We can able to address for the all these components in the agriculture science. Next, go to the association. If your association is, I hope you can see the food plate. Food plate only rice or only roti can't able to feed the hunger. But ultimately, we need the spice and variety of the foods. So that association is necessary with respect to the task. Similarly, either in the operational task of the agriculture science, either the marketing or else in the consumers or farmers growing, every kind of association is required. The prediction is a major challenging task. You have to predict the many things. You can't predict it because prediction is only based on history data. Then what was there and what is supposed to be predicted today. So new data comes that will be compared with the history data. Then you have to predict the new data. What could be the fall into the particular area and how it could be there. For that you are require the regression analysis to predict the exactly. Otherwise, rest of things are could be the probabilistic. Probabilistic is not a way to be. What are the possibility of available in the box? There you have to write one among that which can be provided delivered as a probabilistic. But probabilistics cannot be survive with a lot of things. The predictive analysis require the regression. You have to infer the data and provide the exact results. That exact solutions can be fulfill the need for the farming community. Then next and last, not the least, that is the blockchain technology. The blockchain technology, the people are looking to the different fashion of the blockchain technology. For my particular concern about the farmers' income, farmers are submitting their productions into the market, and market people will be exploiting that, and they are give the whatever the kind of rates. Even sometimes, hope you have been observed that in the Bangalore city or Karnataka, one of the district is there as a Kolar. They are growing huge amount of tomato. Sometimes the rates are not in the scientific fashion. They will be thrown it to the road. So these are the various challenges may causes for this marketing people. The farmers are going to be disturbed and distorted with respect to their income as well as the all the life of this concern. So blockchain technology, you have to peer-to-peer technology, which you have to keep your productions as a Bitcoin system, and that Bitcoin facility means peer-to-peer technology can be participated as a democratically with respect to the productions as a users, as a means consumers, as well as the farmers, as a producers. Both can people can able to participate as a democratically. They can access that data, which can be quoted that prices, and they can purchase it. That it will be better for the consumers as well as the producers. But some intermediary will be not what word I have to say. They are not in the form of the application session. So we are not given the more importance to this intermediary. For that, the data is required. Simply data my analysis already done long back, but that is some limitations with us. So for this we require the machine learning. You have to give the induction to the machine, induce the knowledge to the machine, like a tree induction algorithms, some classification aspects with respect to the classifications. Then you have to induction of this models, then models will learn, then models will be put into the file, then you have to apply the models and deduce that knowledge that through the test data also, which you have the induction made by the training data and deduction does by the test data. Ultimately, you can obtain either classification, clustering, many more approaches over to this. So this is you have to learn, the machine should learn it, and human interaction is not necessary. It can be provide the perfect knowledge with respect to the accuracy, even more than 90 and above. For that requires some of the domains of this machine learning. So the data are unstructured, whereas in the machine learning, there are the two kinds. One is unsupervised learning and supervised learning. Unsupervised learning, data labels are not there and data are unstructured. Such data you can necessary to address. For that, we require to go for the unsupervised. Already labels are there, structure, data is structured, then we have the aware of that knowledge. So then you can go for the supervised learning. Whereas unsupervised learning, you can go for the clustering and prediction. So the clustering, we have the algorithms like k-mean. I would like to explain further in that k-means and mean shift and k-medians. So these are the k is the attribute. You have to start with the arbitrary. Then you can measure the distance between each of the data points with the distance, then among the cluster, and then you have to derive the clusters and which clusters is intra-class cluster or inter-class clusters. Distance is you have to measure the distance is the challenging task to how to threshold them and bring to the better clusters, and we can be addressed for this. The second is another principal component analysis and feature selections and linear discriminative analysis. These are the data we can able to be derived through the unstructured or unsupervised learnings. Whereas supervised learnings, the supervised learnings are used to go for regressions as well as the classifications. The classifications used to go for decision tree, name base, SVM.
We are not hearing you, Dr. Patil. Dr. Patil, voice is frozen. Hello?
Yeah.
Your voice is frozen. Okay.
Could you listen me properly?
Yeah, okay, fine. Yeah.
Yeah, fine. So then the machine learning, another area is the reinforcement learning. That word itself says reinforcement. So already we have that data, we have the knowledge. That knowledge is already in the memory. That area you have to be means backtracking that informations and get the things better way to the assigning, as they call it, as a reinforcement learning. So I would like to take the opportunity to discuss about the classification. Classification is predict the unknown class labels. If the classifications, earlier we have to understand the behavior of the data. Every data mining is requires the study the behavior of data. The behavior of data means you can't, if you see the data, you can't able to understand. So what I can do, we have to do with the descriptive statistics or explorative statistics about the data. You have to understand mean, that range, mean and distributions and standard deviation and variation. So with this respect of the knowledge, we can understand the data how it behaves. After once it behaves understood, then which algorithms we can able to address. So some of the regressions, linear regression is separation of the data with respect to the intercept and slope of the variables, which could be assigned the association between each two variables and given the approach of the result. And similarly, if you go to the decision tree, you have the yes or no question, options with us as a first route, and then again you have to the next level of the node. Again, you have to go and divide into the binary fashions, yes or no. Where it occurs that you have to go and scan over to the particular order of the tree traversal, then tree can be obtained the results. It is a much faster other than the rest of them. So the tree structure you can be, and even you can go to the nearest neighbor also can be addressed for this data, and SEM also separation of the data with respect to this, and whatever you does this result, it could be validated by the confusion matrix. Confusion matrix is whether it is the data is misclassified or classified properly. That is the challenges over there. So confusion matrix can derive the knowledge of this misclassification, how much misclassification is classified, and how to be optimize this. For that, we have to measure the F scores. F score can be provide the results of the minimizing this and optimizing the classifications. And you have to have the four models are there. Which model is best? You have to be measured through the ROC and AUC. ROC is receiving operating characteristics as well as the area under curves of this are the two models can able to address for this. So ultimately the classification applications can market audience and meteorology and predicting the crop yield and genome genomic predictions and plant health, public health, financial institutions, and consumers purchasing patterns. So these are the area. Even I'm only I can't able to cover whole things, but what are the area of concept I can able to address here. So if you take the whole data in the different fashion, then you can make the many more applications you can be address it. So some of these classification approaches are there: the decision tree method, rule-based method, and memory-based method reasonings, and neural networks, name-based networks, name-based belief networks, support actor machines, k nearest neighbors, and even in the linear regression, logistic regression, and as well as the stochastic gradient dish. So these are the approaches. So for that, we have to use the some functions and construction and creating the data in what fashions. But I don't need to explain much because it is a ultimately decision tree is intelligent miner of the support decisions. For that, many people are contributing like Hunts, CART, ID3, C4.5, ROS has been developed. There are so many algorithms, C4.5, Slick, Sprint of the classifications, and rule based is CN2, Reaper, C4.5, KNN, PEBS, and name based networks, ANN, SVM, ensemble, bagging, boosting. These are the algorithms they have been researchers are contributing to the rule based methods for classifying the data with the best classifiers. As well as the memory database, the instance models also fall into the same things, which are the above. I can't able to, I support to write the do there well. And neural networks can make the place of the artificial neural networks. I hope everybody have the human being have the neurons. If you, something happens, you will be scratching. If you want to remember, you have to scratch in the left side, right side, left side, where it will be the you are getting the knowledge. So input the data or input the data, and you have to be compare with the nodes which one is the solution you are obtained. If not, it will be go to the second level of the order interaction between each other within the hidden layer. Then every layer you are obtaining what are the amount of error is there that you have to reduce it ultimately you assign the output as a, when your input is 4 or 5 attributes and output is 1, then output will be the important, what is the your objective output is requires to be addressed there. And basis is the conditional probability. That conditional probability is Bayes theorem used in the statistics or mathematical approach. That should be a belief network. Bayesian belief network can provide the approaches of the some amount of accuracy. Support vector machine is the oldest approach, but even it can be performed till today as the separation of the data and obtaining the marginal value and finding the error, less amount of error and contributing to the classifying the data sets. And k nearest neighbor is playing the vital role in the k. If I start thinking around us, the 20 members seated, then what I started myself as the arbitrary started center, then that is the k0, and then I measure the everyone, which cannot be, I am not a center. Then who will be the center? Next arbitrary. Next, you can go on find the mean of the data of the given data set to the object. Then particular mean I can obtain it to the certain iterations, that you can call it as the k nearest neighbor. And linear regressions is the y equal to a plus bx. B is the amount of slopes or errors are there. Then interpreter interprets the concept to be referred to that and obtain the respect that can be make the model predicts value of the numerical data fields, and computationally binary predicts that logistic regression can be provided. The stochastics is the word itself is the advanced in the probability. That stochastic is the change of state, the transition state, present state, and transition state, and next level states. The order 1, 2, 3, so on. So by that time, we can obtain the stochastic models as the hidden Markov models, and many more models are there to be probabilistic. Try to achieve the every state I can able to address for the probability. Probability is only one event on particular instance is not necessarily. Every different level of instance also we can be addressed for the stochastic fashion. So these are the some area of the benchmark accuracy. Even in the they have been more than this we can achieve it, but at least of this accuracy and F score can be assigned to the F score will be measured by the confusion matrix, which will be evaluate the classifications. And next area is the clustering, and the fourth among the four pillars. Next area is the clustering. Clustering is the maximizing the intra-class similarity and minimizing the inter-class similarity. So, Professor Moni said that you have to Gram Panchayat level. The minimizing the inter-class, inter-distance, or at a global or in the state, country or state, or even in the district or anymore. But that approach is less. But maximizing inter-class means which is within that area of the panchayati level or gram panchayati level or taluka hubli level or taluka level or even district level. What are the areas supposed to be addressed for that? We are required to make the clusters like land and crop and agronomic conditions, so on and so forth. So many. We can visualize the data in respect to the agriculture related data. All kinds of data you can able to be addressed. Even genomics, phylogenetics also be addressed for the this clustering approach, which you can visualize here as a first one image. So these are the two kinds of dendrograms. You can be mix it and bring to the easy to understand that which are the falling in the particular area. If you look into the different fashion, we can't able to understand. So similarly, the K means 1, 2, 3, and the fuzzy K means fuzzy is the suddenly changing the system. So that kind of diversification approach also you can able to be addressed in the K median, fuzzy K mean, and K medians, and K median 1, 2, 3. That K arbitrary order of that K should be 1 to 4 or 1 to 5. And similarly, the advances of this algorithms Clarence and GMM and EM expected maximum, and even in the DMM the database maximizations, DB scans, optics, and DNQ. These are the images which I going to be addressed because I can't able to go through the each individuals to be explained. It requires the academical approach, but I need to be addressed for the guest speaker, so it should be necessarily make that. So intrinsic measures should be necessary for the ground truth level of the labels, and extrinsic measures of the measurement of the does required by the ground truth level. These two, both you have to cluster into the data as well as the ground truth can be matched and can be provided the results, informations. So some of the approaches of the clustering, basically they have been divided into the two types. One is partitioning, and there is the hierarchical. Partitioning, you have to divide it. Hierarchical, one below the other as a tree structure. So for that, you have some algorithms. The partitioning is the k-mean, k-mid, k-medoid, and even in the clans. So whereas in the hierarchical, the Diana, Aegis, Bridge, Crocs, Kremlin, these are the Chameleon, these are the algorithms are uh, supporting to this hierarchical approach, hierarchical clustering approach, whereas DB scan, optics, and DN clues are supported to the density-based clusterings. Sting and wave cluster and clicks will be supporting to the grid-based approaches. And model-based approach are expected maximization, self-organization SOM, expected maximization EM, SOM means self-organization mapping, and cobwebs that economics people can able to understand the cobweb model can be provided to the model-based data. And frequent pattern based data, you can P clusters, and user gradient or construction based. So these are the little approaches are required to be addressed for that. So that clustering algorithms, we have you can see this centroid. So K is go on increasing the 8th version. They have been advancing. K means K and to K, then K mean 1, 2, and OR operators, and K monoid and 1 and 2, and Clara and clans, they are the 8th version they have been advancing the algorithms. Similarly, the distribution, that is the expected maximum, general expected maximums, and OM, DMM, database maximizations, and DB clues. These are the algorithms go on evolutionary increasing. So these are the area how the density also been improving the algorithms. So and connectivity, the breach, UPGMA, the UPGMA perform. Okay, fine. Let me do that. You come? Yeah. Thank you. Sorry, it can be feasible much better. Yeah, no issue. Fine.
Professor Patil, you have to also slightly hurry up.
Yeah. I'm covering up little faster than that. But exactly. So, can I put something here? Okay. So these are the grade based and faculty based. There's a clustering version be go on increasing and achieving the lot of aspects of this algorithms. They are contributing lot of things, and whereas association analysis, okay, fine. Let it be there also. And association analysis, already we are aware of that. It is the discovering the interesting relationship hidden in large data sets. Uncovered relationship can be represented in the form of the association rules, sets of the frequent item sets. The frequent item sets, the people are purchasing the bread. Bread is not enough. They want to purchase the butter, they want to purchase the jam, they want to purchase the milk. What among that, which only the major amount of license items can be satisfy the minimum support thresholds. For that, we require to generate the rule generations, extract that higher confidence of the rules and strong rules for the frequent item sets found into the previous steps. For that, we require the support counts that association rule is frequent items are generating. Then a prior principles of horizontal and vertical data layouts. It can be PF trees, PF growth, PF trees, and PF means frequent patterns tree, and build up PF trees and mining the trees. So that total amount of concept will be avoided into the task based on the association. Then compact representation of the frequent item sets and number of immediate support superset of this frequent and give the more pruning means which are the number of data could be more grown much in the nodes that time edges. It's not necessary. Those who have to necessary to prune them and bring to the optimistic of this result, providing the maximum items of this and close item sets. Close item sets are number of immediate supersets has same count and stores not only the frequent information but exact count also requires. So application is a supermarket already in the field, web mining and medical analysis and news, so many areas. But ultimately, find the pattern of the programming concept to be aware of. But ultimately, state here now, the object of this association rule can be provide the farmers to be decide which crops support to be grown and what relation of soils is required to be and what is the market driven production is required. These are the association rule can be cater that information to the farmers. So these are the some examples which you can necessary to quote it here for that examples of the concepts. So basket technology. So these are the area and how what are the transactions and how many people are purchasing the butter and bread and how many people are purchasing the bread and so many so items candidate items you are obtained and minimum support what could be a percentage of amount of the supporting required to be addressing the frequent item sets. Some of the algorithms we have that in the algorithms like a prior algorithm, ILCLAT, PF growth, and pattern frequent pattern growth, and AIS, STEM, brute force, and as well as the better way weeks. These are the algorithms been mining to the association algorithms, and some of the merits and which are the functions can be addressed with respect to our various agriculture products. Presently, the market products are running on this, but healthcare also addressing. But agriculture is still to be advances and awareness is necessary to be advanced towards this area. And last data mining approaches are like a predictive analytics. The predictive analytics have the approaches historic data and then you have to predict analysis and you develop the model and new data comes pass into the model obtain the results predict that predict will be the avoid. For that we have the online retail cyber security healthcare education and fraud detections and improve this uh, area of that. Okay, so weather forecasting and so on and so forth. This area, but it should be light in the probability should be light in the normal distributions. The data should be fall into that part. We can't beyond the 95% of the significance is required. So the 5% error could be tolerable by the significance and obtain the results. So for that we require the data problem statements, data collections, data cleaning, data analysis, build a predict model and validate the model and deploy the model with respect to that. So we have some predictive analytics machine learning algorithms are like regression models, choice modeling, and rule inductions, network, and link analytics. So these are also playing the vital role in predictive. Ultimately, regression is, I already told you this, regression is infer the correct and deterministic in result of the data. Rest of them are could be the probabilistic, but regression will be providing the better approach to address the regression as the base of the infer this correct. So these are the already the data mining of the softwares. Some of the softwares have been listed here. Many more are there, but these are peoples are widely using this or the algorithm softwares. One is the SaaS enterprises, enterprise miner and rapid miner, SPSS modular, or Python. And nowadays, Python has become the more familiar, and it will be the go on mad in the part of the usage and usual as a tour. It will be more catering the all the necessity to the analytics people, data science peoples, and these also pre-education versus except SPSS modeler. Rest of them are the pre versions, open source data and pre-education softwares are there. You can make use of that, and you can obtain the better results with this, and you try to approach and adapt the possibility of this mining approaches through the data mining softwares. And digital agriculture, already I spoke about the geoinformatics, bioinformatics, agriculture engineering, and agrometeorology. These are the area we can able to address that. That to geoinformatics, that people are have the footprints of this water footprint, carbon footprint, and mineral micronutrients, forest degradation, natural disaster, fish migrations, grassy lands, orchids, new habitats, development. So these are the area we can able to accumulate or derive the knowledge from their remote sensing as well as the GIS. The bioinformatics as a computational biology, the genetic engineering, crop phenotypics and functions by metabolic analysis and ergonomically. Agriculture engineering is mechanization, cultivation, harvesting, post-harvesting, sensors, robotics, sensors like moisture sensors, as well as the mineral sensors yet to be necessary to fabricate. People are try to achieving those are area also. Robotics has come, but it is not order into use the in our Indian scenario. So that the small farmers could not be able to affordable, or else it's not feasible to use those areas. The agrometeorology is relationship to the weather and climate, crops and livestock productions, soil management, and even having the one more approaches I need to address here, that 15 agroclimatic zones are in the India. Out of 15, 10 are in the Karnataka. So such a diversified state of system in our Karnataka of the agro conditions. So these are the individual areas, but we can not necessarily, because specifically we don't have any uh, case studies, but these are the area we can able to address for this classification of the soil, crops, micronutrient, minerals, seasons wise, soil biology wise, and agroclimatical condition zones, irrigation system wise, and even in the clustering like agroclimatical conditions, density based macronutrients, and partition based soil biology, and similarly association as the agroclimatical zones, frequent patterns of the micronutrients, partition based. So these are the area we can need to address for the soil level, soil science level. Similarly, genetics is the variety of the yields, molecular genetics, drought resistance and disease resistance, and even in the improved of the genetic patterns and domestic plant populations of the specific plants, like classifications, clustering like a genetics and geo informatics tags, density density based genetics patterns of the domestic plant populations, and population based grafting and genetic engineering, like a whereas association, the sustainable variety of genetic GI tags, the frequent pattern of the sustainable variety, the partition based yield of the driven phenotypic QTL excellence, and evaluation of the association patterns cross pure varieties to evaluate the hybrid variety. Predictive means dot and disease resistance, genetic and geoinformatics tags, density-based macronutrients, minerals, as well as the partitions-based sustainable varieties, genetic GI tags, and other endangered species. So these are the area we can able to address in the plant breedings and physiology concerns, plant physiology concerns. Oh, sorry, okay. Well, that is a physiological concept to be a phenotypic and genetic variety of the molecular genetics and improve the genetic patterns of the domestic plant populations and as well as the physiological phenotypic forms in the xylem and phylum facility of the transportation of the water, minerals, food to the through the plant and even clustering like a QTL GI tags, density based as a genetic patterns of the domestic plants and populations of the grafting and other things. Similarly, if you go to the association, sustainable variety of the genetic tags, frequent pattern sustainability variety like soil biology, irrigation systems of this particular plant's critical conditions, as the violations of this pattern cross of the pure variety evolved by the hybrid varieties micronutrient minerals as a deficiency and density base is the micronutrient minerals and piston base is the xylem and phylum. So these are the some area we can able to address it. But even if you go depth of this individual expert in that area, researchers or experts in that particular area, we can be interact and bring together and form the good team to be address with this data mining and they have the good knowledge of the every respective domains, subdomains. And plant pathology is some of the derivation of the bacterial, fungal, and viral disease, pustule and disease-based crops. So you can classify them through the best classifiers and plant disease-based symptom signatures, diagnose the patterns of the downy mild and powdery mild and plant disease. These are the approaches are required to be addressed over there. And convolution neural networks (CNN) can be underlying the deep learning engineering of the classifying the disease category. Whereas in the clustering, the plant disease affected propagate across the geographical areas, density-based disease patterns of the domestic plant populations, and partition-based agroclimatical zones separating the diseases, spreading the disease. These are the area we can able to approach for the clustering. Whereas association, we can have to have the frequent pattern of the plant diseases and sustainable disease of the frequent patterns controlling, and as well as the climate change declining the pollinators by the partition base, and even in the disease including the license of the spots by evaluation of the association patterns and prediction concerns the diagnosis of the plant disease based on the climatic and geographical conditions, image based plant diseases of the detections, and density based bacterial and fungal, viral and fistula and diseases, and partition based the bacteria, fungal and viral fistula diseases also to be approached over this. And whereas in the entomology, that is the pathogens. Now it can entomology become the insecticides. The insecticides classifications began in 18th century. The pathogen and genetic variety. The plant disease based on the symptoms of this and which could be the pattern of the domestic plants. So convolution can be does it, and you can entomology is the some of the insects can uh, harmful and some of them are in the insects are going to be human beneficial impacts. So such insects can able to be addressed and studied over to the entomology and economics is the cost of cultivation is major challenging task even whereas Professor Moni ji said that small farmers, is cultivation cost is very high. If you make the cooperative farming systems, can be minimizing the cost of cultivations and keep their property titles will be remain with them, and we can make the society bring to the big farming area, and you have to be go to the market driven the approach, and you have to be participate, and you are given the guarantee of the income to be provided to the earlier before going to the uh, cluster the farm society. Then you have to be addressed for this. So these are the area inputting of the revolving funds and management, and production and productivity pattern categories, and categorical crops in the clustering concern, demand based categorical crops, density based disease patterns of this domestic plants of the respect to the agro cost of this economics. And whereas in the farm management cooperatives, frequent patterns of the production produce food and fiber, and partition based of the climate change of the declining pollinations of this. So some of the area we can able to address for this actually. So distribution systems can be, does it supply consumers goods, supply of the industrial inputs, labor inputs, and primary stage of the economic developments, and capital form of the formations, and risk, and uncertainty, and existence middleman, and sub- substances of the farming. These are the area we can able to address for the agriculture economics. And major area DNA, the people are, whole world is looking forward this. Now people are only speaking during the pandemic state. Oh, virus sequence also established, and mark the gene and establish what is the virus can't visible, that they have to make the sequence of those. So ultimately what I have to say that the DNA analysis can provide the lot of controlling in the genetical approach, phenotypical approach, behavioral approach, many more. So that is the object. We can nearly, my students are worked on the cancers of the genomes as a protein-protein interaction of this cervical cancer. One lady is already awarded that cancer genome, cancer of this protein sequences. Another person is to be submitting that lungs cancer. One more madam lady is already awarded the brain cancer, and prostate cancer and general cancers are to be in the progress. So DNA analysis can provide the better directions to be address the critical conditions of the life, health, as well as the plant. So whereas comparing the frequent occurring the patterns of each class, like a disease and healthy, and even in the association most of this is triggered by the single gene, but combination of genes acting together, and may help the determine the kinds of genes that likely to be co-occur together the target samples. And path analysis, like a different genes may become active and different stages of their diseases. Development of pharmaceutical intervention that targeted to the different stage of the separatable. So and even visualization tools can be, genetic data can be. So ultimately the DNA analysis can prove the uh, supporting of this decision making by the plant health as well as the human health in this area. So handling the big data as a parallel computing, I don't need to address this because already there many people are aware of that parallel computing and image computing. Ultimately, it requires the map reducing programming models is required for the big data. For that, we have the Hadoop. Hadoop is the people are. I hope we can look into the image that the elephant is there, but what exactly is going on? That five blind people are explaining the elephant. One is holding the leg and says it like a pillar. Another is, so individual have their own approach of that. But Hadoop is distribution functions can provide the better way to be map reducing and parallel computing, parallel processing, and distribution can be approached to this. That will be scalable, economical, and efficient and reliable. And Hadoop is a free software that is also major useful to be addressed for that. If you use a Hadoop as a big data, as a centralized data systems, Hadoop can be perform much better into the operations. Some Hadoop ecosystems like ETL tools, BI reporting, and BIMS, ultimately that Hadoop distribution file system can be proved into this. So my approaches of the big data in agriculture, the big data is playing smart farming, and stakeholders are involved in their organization, and there are expected changes in the causes of the big data developments and challenges to be addressed in the relations of the previous question. So these are the major questions in the mind, how to be view this and what is the solution for that. For that, already research is going on machine learning, and regression is already told you that it is the more predictive and it will be in for the deterministic in results. So spike and slab regressions, time series analysis using big data regressions, big data, and application of the agriculture and applied economics. So some reinforcement learnings, the genetic algorithm, Markov decision algorithm, and regression algorithm. So many list of linear and polynomial, non-linear, variable, and stepwise, principal component, and Bayesian informations, archive, and partial least squares, classification multivariate, and elastic inner and elastic absolute, lasso, glasso. So many algorithms have been used for the in the
Can you move to the previous slide?
this one or question one.
Okay. Okay. You can go to the next one.
Oh, these are the reinforcement learnings. That is the spike slab regression analysis require the Bayesian techniques as well as generalized ridge regression techniques and Bayesian moving average techniques. These are the approaches for this analysis of the particular regression techniques. And time series analysis of the big data is structure of the time series BSTS, and Markov chain is the Monte Carlo method, so we can sampling the algorithms, and Bayesian model average smooth predictions over to the large number of the potential models. So the big data applications in the smart farming, one is the diverse drivers are there like a big data application systems, network management, organization and technology, stakeholders networks, business process, farm management, data chain. Then what exactly you have to arrive to this? You have the many challenges are there. So that challenges you have to be looking to the data chain on a data capturing purposes, servers, types, quality, data storage, system location access, and data transfer, purpose, channels and conditions, and data transformations, purpose and methods, data analytics, purpose and methods and outputs, data marketing, is also necessary to address here. So the farm management is the sensing and monitoring concept of the measuring the actual performance of the farm process. Analytics and decision making is the compare the measurements with the norms that specify the desired performance. The intervention plan and implementation, the chosen intervention of the correct and farm processing performance. So for that, key stages are there: the data chains, the technical and business stages of chains are raw material, processing, transportation, and marketing. In this area, data generation and capturing in the raw material technical concepts, whereas the business data discovery and data warehousing, and data journeytelling and transformations and analytics in the processing, interpreting, connecting, decision making, and business informations insight for that business. Transportation is the data transfer, information share, and data integrations. Marketing is the data transfer of data and data driven services, which are the
So
areas.
Patil, just to speed up, you can speed just to
Yeah.
speed up.
Okay. Yeah, definitely. Good security concerns and predictive modelings of these drivers, and decision making is the major challenges, and real time processing which you require to go for the blockchain technology and smart farming driven push pull mechanism. The push pull mechanism is major challenging to perform the smart farming. The push factors are general technologies, pull factors are business drivers, and I don't need to explain much for that. Okay, the sophisticated technology for the push factors, as well as the data generation of the storage is also the push factors, whereas pull factors are public drivers. Public drivers are food, nutrition security, and food safety, sustainability. These are the challenges. Whereas the push factors are digital connectivity. Already you are in the form of that digital connectivity, and innovation possibilities also going on in these push factors. The pull factors are general need for the more better informations to be derived through the data mining also. The smart farming facility. So these are the area have been compiled by the different researchers, which are contributing by the uh, smart farming, smart sensing and monitoring by variables, the robotics and sensors by Pulkner and Pulbal in 2014. Similarly, biometric sensing, GPS tracking in Sonica in livestock for the 2014, and horticulture robotic sensors and temperature, humidity, and greenhouse computers by uh, Sun et al. 2013, and automated fisheries, automated identifications of the systems, AIS by the Natale et al. In 2015, and smart analysis and planning like variables are like a seeding, planting, and soil type, crop health, and the modelings by Noyas 2014, breeding monitoring in the livestock like Cole et al. In 2012, lighting energy of the management by Lee and Wang in 2014, surveillance monitoring Yan at 2013, and similarly smart control precision farming done by the Sun et al. In 2014, 2013, and milk robot in the livestock is Grabber 2012, and climate control precision control by the Luo et al. In 2012, as a fisheries surveillance monitoring Yen et al. In 2013, like a big data in the cloud, data warehousing and other things for agriculture, marketing and other things, Chen et al. In 2014, livestock movements in the warm and weeks in 2010, weather climates and Veridor et al. In 2013, market data, satellite data, which you can European Space Agency 2016. These are the people already working in that area, the particular individuals' case studies, but they are restricted to their research. But you can need to address for the big data and to be derived to the knowledge to the farmers level or ground truth level. That can be possible to achieve the better result. For that, you require the smart farming management. Smart farming management is subject data analysis. The multi-source data is there. The duplication data you have to remove it, denoise it, clean it, transformation it, representation it. Then you can bring to back to the fusion and clustering, statistics, mining, analysis, and subject data. That become the data verifications can be done by the smart management system. These are the key issues are there in that smart farming also. One is data capturing, the people already contributing to the sensors, open data capturing by UAE machines like a Proofner and Sebel, biosensors in Glen, genotype information in Flow et al. In 2012, reciprocal data is VANS in 2014. Key issues are available of the quality formats 10 in 2013. Data storage by the cloud-based platforms, Hadoop's distribution file systems, Hadoop systems, hybrid storage systems, cloud. These are Zhang et al. In 2014, and quick the safe access of this cost of Zhang 2014. Data transfer wireless cloud-based platforms by the 2014 by Karim, Ju, and linked open data is been Ritban in 2014, whereas the key issues, the safety of agreements on responsibility and the liability of the error 2014, and data transformations, machine learning algorithms normalize the visualize, anomalize the van and regiments, heterogeneity of data sources of automations of the data cleanizing and preparation by Lee et al. In 2014, data analysis yield model and plantation instrumentation, benchmarking decisions, anomalies, and cognitive computing by the when Rajimang, and segmentation heterogeneity of real-time analysis by the Lee et al. In the semantic community, and data marketing by the data visualizations, and that also Van Sparks, and ownership privacy of the data business in the Oats and Spoken. So these are the sources and applications area. Okay, so these are the area we can able to address for the smart farming. So in the data chains, so they are the stakeholders. We have some of the stakeholders: agribusiness, farming, agri-tech, and venture capital. Already, Professor is already spoke about it. And these are the big data ecosystem. People are contributing the software companies. These ecosystems also contributing over to this. This is also available. And network management of technology can be user front-end tool and app stores, B2B collaborative cores, and system data integrations, and software development tools SDK can be operating with respect to that. And big data in agriculture, Indian farmings or Indian farmers are making the inaccurate decision due to the inability of timely, accurate, and actionable data information. Availability of data is analytics that provide the crop intelligence forecast, disease and damage of the detections, and l- have a large scale impact on the Indian agriculture sector. It can make the farming more predictable for farmers across the country. So cluster farming can be provided the facilitator to this. Practice the several farmers come together, grow the single crop, cooperative farming, demand driven based, and even in the involve the farms entrepreneurship group and share the both the benefits and burdens, and field specific activities like irrigation types, chemical usage, different other farms operations, etc. The field specification weather parameters like soil characters, humidity, and field of the. So these are the improving the cluster and ecological forecasting systems. These are generals which can able to address that. And one more point here I added, the government already aims to harness this big data in AI agriculture sectors like Niti Aayog already spoke, and precision agriculture and polyhouse monitoring systems. They are already in the way. The IBM people are participating this part, and the cognitive farming techniques based on the system crop monitoring and weather forecasting monitoring and sensor technology. They are all playing the vital role in this agriculture farming systems. And already spoke about the farm to table. Farm to table is the major approach of the moving agriculture in big way. Need to prove of the several well-known investors recently dropped combined the 40 millions. I hope you have the statistics. I don't need to explain. Already I spoke about that. That I'll come to the next is the important the challenging, and it can be proved the farmers can be justifiable for their income with this. So till now I spoke about that only big data is the centralized data systems. Now blockchain technology come up with a better way to the decentralizing the data with the distributed ledger records and once that the digital assets. Means every corner the individual user can also support to hold the data into this, and they can participate and democratically by any word users can independently participate of that democratically, so which can be used productions like it actually starts with blockchain technology starts for that agriculture, sorry, every research repository they want to repository. By that time references are become the skewed and cortices of this area. But in that concept, by that time people are started thinking the research on that, how the research could be make use of that individual cannot be given to the public open domain. By in such situations blockchain technology comes up. For that mark, every technology need to be grow means the business people is need to inducing that their hands and bring to the scalable and driven by the profit over to this. So they start with the bitcoins. Bitcoin is the coin which have the minimum knowledge of that individual users of the democratically, they only knows understand. details will be not openly disclosed. So that's such inherent design of the data blocks, unable to move modified and legitimate to disrupt the industrial payments and cyber security. This is a very compact and robust in the nature of the data. You cannot be uh, the users means purchasers like consumers as well as the farmers can be establishing the bridge between them to make their production marketing system. So applications of the agriculture marketing, crypto farm production currencies, like currency, instead of currency, I had to put it in the farm productions, or digital currency like our tokens in the grains, spice, oil seeds, etc. Any more. All the things we can put in together fashion. And digital forms of the digit form of the cash, crypto are used by the every things for the very lunch of your next homes. Then, unlike cash, crypto uses the blockchains act as both the public ledger as well as the enhance of the cryptographic security systems. So this will be linkage between the farmers, small farmers or every farmers to the consumers level, and it will not encouraging the middleman to be meddle it into the system. For that, you require the smart contract concepts and cryptocurrency concepts. So we have the sellers and purchase rules are there, production and consumers, and that also without middlemen, and crop production concepts is there. So we can put into the cryptocurrency fashion. Nobody can meddle it, and every individual can able to participate as a democratically, and they can peer-to-peer technology network can be decentralized the communication model and between the two peer-to-peers, also known model nodes like a seller and purchasers, which can communicate with each other without need for the central server. So this is the big challenge for the present scenario, and I no need to explain this part of that the cryptocurrency. And these are the some of the domains which have been already introductions and distribution ledger, how it work for the distribution ledgers, and what can be done, what is the smart contract. The smart contract means you already in the part of that. You have been put your data into the digital fashion. That's the smart contract. You no need to be explained further. That details will be provided into the your nodes that will be accessed by the every persons and they can quote it there in the peer-to-peer technology. Nobody can interpret it over there, intermediate there. So we can directly access each other and can go to the access the smart contract concept. They are the multiple parties and ecosystems. Establish the trust between the all parties issues. Critical have the tamper-proof permanent record transaction. This is a very important task. Tamper-proof permanent record transactions are the securing the ownership management of the finite sources. Thus, ecosystem benefits of the improve the transparency over to the consumers as well as the farmers. But it does now in the bitcoins, but it should be percolate till to the agriculture, farmers and consumers. The smart contract is there, privacy is there, okay, consumers. So these are the challenges are there, and some of the data mining can be like to the visualization. Through that also we can able to address this. So these are the area we can able to audio, scientific, statistical data mining. So many areas you can going to be addressed for the data mining applications. Then trends are there. Okay, so these are the area I can able to address it. So the domain specific applications, data mining systems, visual data mining systems, and scalables, and classified, intelligence. So many areas you can need to address for the data mining. These are the reference which I have been used for that. Thank you. Thank you. And any questions? So I'm so kind of you. Thanks to all the participants which are across the world. Anything goes wrong, try to forgive me. And any questions you can, I am welcome for that.
Thank you very much, Professor Patil. It is after today is the 83rd edition, and I was enjoying listening to you, and you have covered an area and a subject where farmer generates data, farm generates data, and data science gets developed, agriculture science gets developed, and farmer is not getting developed. He is not getting benefit of either
That
data
is the
science
main
or
point.
agriculture science. As a professor, he worked in agriculture science, data science, and statistics, mathematics. And as also, I being a mathematics student and computer science student working in agriculture sector to bring in, that's the reason only I was instrumental for the last 2 to 3 decades of bringing in agricultural informatics as a discipline. Agriculture economics has got its own
One more
understanding
I
and
would like to add it here that the
and then
mathematics is the mother of science.
agriculture statistics is another area application, but agricultural informatics has to bring in everything under the umbrella. And when I initiated, when I 95, when it has put it as a national conference on informatics for sustainable agriculture development, people thought that this gentleman doesn't understand what is agriculture and what is computerization. And unfortunately, my own organization, my director general, did not sanction even a single pipe for conducting the conference. He said that there's no budget money. If you want to do, you do it. But as a live fish against a stream of water, I wrote letters to various chairmen of the nationalized bank. I got 6.5 lakhs rupees on those time, 95, and we were able to bring out 15 informatics network as a blueprint for IT in agriculture. Today, I'm able to see a lot of development is taking place. And many of the articles and many of the things I'm trying to find out that an Indian name in over there and many of the articles. And until
Yeah.
unless we get to do that, until unless we identify area where we can contribute, that's why when somebody said that, I told you agriculture economics is another area which is well developed. And agriculture statistics is another one. But today agriculture informatics is evolving. I was instrumental as a district information system program for 28 sectoral database. Now 95. Now let me work on in this area, try to bring it out. Today I'm a satisfied person that now a person like you with your vast experience were able to bring out, amalgamate and integrate, interoperable. This is what is needed. And this is today I was noting down the way in depth. Normally it is 1.5 hour session, which is now gone for, it's more than almost more than 2.5 hours, and it is 2:15 now, 2:20. It's 2 hours 15 minutes, which has now gone. And I was saying that we can, this area alone, these centers of excellences can bring in 15 certification programs for our rural youths to undertake. And this is, it's a data mining and digital agriculture. You brought out so many areas: soil classification, soil, and four, data mining techniques: genetics and plant breeding, plant physiology, plant pathology, entomology, agriculture economics, DNA analysis, blockchain technology, and data chain, smart farming, arable livestock, horticulture, and fisheries. How we can go about it? What all the research publications have come, and then the last one which you talked about is very important: crypto farm production products. The whole world is going on. And here, regulators like RBI and Supreme Court has got different views on crypto, utilization of crypto, technology, cryptocurrency. And you put it very nicely that how we can have a crypto farm products. And in the same webinar series, an NRI from Canada who is working on Agri Trade Hub, he said that I will be in this exchange is being created so that this information about agricultural commodity will move as a QR code. The products will not move. After it got into a secured warehouse, the data about that, its characteristic, everything will be made it as a digital coin, QR code, and that will be traded in world throughout the world markets. The commodities will not go, and that is the where that our NRIs and the our academicians, researchers, technologists have to do that. Data engineering, data science, data analytics. And today in these 116 slides, even though you have to rush up, but you are given a complete overview of what is necessary and what direction our education system should move towards. And that thing is that opportunity. That's the reason only I thought that you pressurize that to have an 2.25 lakh agri-tech startup, so that the topic which you talked about it is not a one man activity. It is not 400 and agriculture colleges teaching. Every 4,500 engineering colleges who teach computer science has to undertake this job, and and all 1,500 universities, deemed universities, public university and private university has to undertake this job if India is an agrarian economy. Everything else can wait. Like our first Prime Minister said, second Prime Minister said, and Mr. Atal Bihari Vajpayee said, and the present Honorable Prime Minister said that it is Jai Jawan, Jai Kisan, Jai Vigyan, and Jai research, agriculture one, and Jai operationalization. It has to go down back to the farmer. And today is a digitalized agricultural operations. That's why that doubling farmers' income by 2022 has gotten one chapter on digital technology in agriculture. And I'm surprised that the 4,500 agricultural university, engineering colleges, All India Council of Technical Education, ICR institutions, state agricultural universities, and Ministry of Electronics and Information Technology are completely not even looking into the 7 mission mode programs. This is the first university in the country, private university in the world, to have 5 centers of excellence to motivate technology to the grassroots level through a higher education. M.Tech in Agricultural Informatics, B.Tech in Agricultural Informatics, BG Diploma in Agricultural Informatics, MBA in Agribusiness Management, M.Tech in Informatics and Standards, and MBA in Industry 4.0, and MSc in Health Informatics. Data analysis, see through digital technology, GIS technology, image processing, and whatnot. Many things which I'm very happy that it's available at the grassroots level. And even though I retired as in 2013 as the Director General of National Informatics Center with a passion, I'm continuing to do with this Shobhit Institute of Engineering Technology to promote agricultural informatics in a big manner. The country has to adopt agricultural informatics as a preferred discipline to make rural India to shine, to smile, and to roar. And today, Professor Patil, I'm very happy, even though we have been interacting, but I would like to request to you that let us work together to bring out as many number of certificates as possible through the today's topic, through the university, through these 5 centers of excellence, so that the rural youths, boys and girls, and also of various discipline, they can take agriculture as a preferred option for skill and entrepreneurship development.
They should be bring into the single umbrella and bring into that results. That should be necessary.
And the country needs 2.25 lakh, agri-tech startups, and then data mining and digital. Everybody now, that every government department is generating data. It is digitalized. And the e-governance is getting redefined. See, previously e-governance is that what the government has, it has to be made available. Right to Information Act. The Right to Information Act 2005 says, Class 4.1a, every aspect, every data which the government collects should be digitalized. And many of the websites of the government, both the state and central government, district administration, does not say that we are Right to Information Act 2005 compliant with respect to the clause 41A. So, and today it is not only the government e-governance, it is a private sector e-governance. It is a digital India e-governance. If the digital India has to emerge as a new India, digital governance has to be there. Every individual has got a smartphone. So he is a part of digital governance. So he is also is a citizen to enterprise e-governance. Citizen to government enterprise, not the other way around. And it is a citizen centric. It is very important. That's why today you are able to talk in a very effective manner that data mining and digital agriculture. I learned a lot, and we have to walk further. And I will be very happy based on this one. Let us prepare an approach paper that what we should deliver under the Center for Agricultural Informatics and E-Governance Research Studies, Center for Agribusiness and Disaster Management Studies, Center for Informatics Development Solutions and Application, Center for Industry 4.0 Technology Studies and Application, and Center for Health Informatics and Computing. And how we can deliver data mining on digital agriculture, because food and agriculture embraces everybody. And I would like to quote that Dr. Krishi from Australia. He delivered a talk, use of artificial intelligence and big data analytics to ensure optimal protein, nutrient in the soil and harvested food to minimize human disease. Use artificial intelligence and big data analytics to ensure optimal nutrients in soil health, and harvested food, plant health, animal health, soil health, fish health, and to ensure minimum human to reduce human disease. So this is an important thing, and today's topic can generate lot of pilot project proposal to be undertaken under the Doubling Farmers Income by 2022 7 mission programs. So I would like to hear from you, and then I would like to close the webinar and thank all the participants. Over to Dr. Patil.
So thank you. You already endorsed all the views. So my object is all the agriculture science researchers are come together and bring to the action plan to keep the data into the holistic fashion, and then you have to mine it and obtain the informations which is necessary for present scenario, and it will help to the direct farmers in what way that they have to be addressed. Simply they have their own research applications. It can be help for the certain productions level, but if you want to address for the whole farmers community, all the organs is necessary for human beings. Only right hand is the working, left hand is not, so that's not necessary. My request is all the agriculture scientists and digital science, data science scientists come together, bring out some proper action plan or blueprints for that, and give the exact solution to the farmers to be in the smile of their face. That you have said the Australia cases, even the people are now going for organic farming. That also not actual. What I have to say, that land is side by side lands are in the heavy mineral fertilizers, and this is organic. It's no, everywhere is inorganic. Try to bring to the organic planning and induce that, and production side also you are looking to this, and how to be better approach it to that. You can make the health the basic part of the every human in the whole world.
Thank you very much. Thank you very much. and let us work together. And
Yes,
it's very important with your vast experience, 35 years of teaching and academic research, and also lot of research activities you have undertaken, and also with my vast experience of more than 42 years walking in the rural areas and bringing out district information system of the at the district level, and in 1985 512 districts in the 29 sectoral database development visualized. If those programs would have been operationalized today with the artificial intelligence and data analytics technology, today we would have built up a better world. And all those developments would have been operationalized. If data is not good, there is no point in applying AI over there. If the data is not, poor data means poor AI. Poor data means poor decision making. And there is poor value chain. You can't integrate it. You can find out, and many people cannot do analysis and bring out the decision support system to the farmers. And 14.5 crore operational holders are with us, and livestock animals as another asset, and fisheries, inland fisheries and marine fisheries. And it is an important opportunity to generate from agriculture waste to wealth, and also to value chain, from primary agriculture to secondary agriculture to tertiary agriculture. And this is where we have to bring in, and India can be the food bowl for the entire world, and agriculture 4.0 has to go from India, incorporating industry 4.0 and society 5.0. And you rightly said it, how researchers should function, how the startups should function, and the cooperative societies should function. We have nearly 1 lakh primary agriculture cooperative societies, 22,000 primary fisher cooperative societies, and more than 1.5 dairy cooperative societies. And now 10,000 farmer produce organization. Government wants to do that. And I have been voicing that all the cooperative societies has to be networked and digitalized, CoopNet and EU cooperatives. They have to become like a value chain. They cannot always go for a waiver of loans. All farmers, if what they produce is a value chain, and every cooperative society is associated with a agri-tech startups, the farmers will give money to the cooperative society as a corpus fund. And I'm very happy, and Mr. M.M. Shetty is now giving one very informative lecture on use of data mining and digital agriculture. Thank you, Mr. M.M. Shetty. Thank you very much. And with this, I will close the webinar and leave the studio. Thank you very much. And I think there is another professor, Mr. Chandrakant Mysore. This topic is very useful for all, and for all graduates. Thanks for the choice of the topic, and the professor who has worked very intensively here. Thank you, Professor M.G. Chandrakant. Thank you very much. And I also thank Mr. Manish Chapra, who is now behind the scene. He has been, collecting and getting the, feedback which is available in various delivery channel, which is going on from Facebook, from LinkedIn, and from YouTube, and he is flashing it. So thank you very much. I thank our Honorable Chancellor, His Excellency Ardo, and Honorable Vice Chancellor, faculty members, and my guest speaker, Dr. S.S. Patil, is long-time my friend, and all the participants who are also flash their feedback. Let us work together. Let us promote M.Tech in Agricultural Informatics, B.Tech in Agricultural Informatics, BG Diploma in Agricultural Informatics, Diploma in Agricultural Informatics, MBA in Agribusiness Management, and M.Tech in Informatics and E-Governance, and MBA in Industry 4.0 to train CEOs of SMEs, and MSc in Health Informatics to bring rural India, 14.5 crore operational holders, to smile and also roar. That's how the rural India's economy has to flourish. And as told by the former chairman of Hindustan Unilever Limited in 2012 in the shareholders meeting, rural India, if technology is adopted, can give $1.9 trillion to the existing Indian GDP in 2012. So if rural India is developed through technology and every aspect of natural resources is optimally utilized with the effective value chain, with the rural industries at the village level, and everything gets processed, no milk should come out from the Gram Panchayat as a liquid milk. It has to come as a dairy products. No fish should come out from the places of production as a raw material. It has to come as a fish products, branded products. No, that's how agriculture has to be converted as a secondary agriculture, tertiary agriculture, and NRI agriculture. That's more important. And with this, I would like to close the webinar and
One more
leave.
point I would like to share it.
Yeah, please, Dr. Patil.
Lastly, thanks to the NIC Bangalore, they are providing me the resources like the BV, but the SIO.
Yeah, thank you very much. I'm very happy.
And, our
As
Gautam
a former
and
Director
Kendra,
General,
are all
I
cooperated
addressed
and
on
given me the resources with
18th
under
June
your
from NIC Dharwad, and
yeah.
also today Dr. Patil has selected to address from NIC Bangalore, and I thank the State Informatic Officer, NIC, and also the other technocrats who has helped Dr. Patil. Can I see his face, Mr. Hello?
Please, SI is there. Call him, please. Please, he is coming, sir. Please. So actually, you are given the very good narration, closing narration for that. But this one, you let the people should take the positively, not even if the comment it is no miss, it not feel anything bad for me. But approach is it should be reached to the farmers, and you have to give the fruitful results of that. He is not available. Yeah. Okay. Please, you come. Is Mr. Gautam?
Very nice that, and you please sit down. That I hope you are able to, and that's, remember me. And I'm Professor Moni, former Director General, National Informatics Center.
They know very well about you.
Director General in 2013. Still, I'm very active. Thank you very much, and convey my regards to the State Informatic Officer and also other colleagues. Thank you very much. Thank you. We leave this.
Sure, sir. Thank you, sir. Thank you, sir.
Thank you.
Thank you.